Second parameter is the resolution factor. The resolution factor is calculated for 2 consecutive peaks, and it is equal to 2 times the retention time of the second peak minus the retention time of the first peak, divided by the width at the baseline of the second peak plus the width at the baseline of the first peak. For this chromatogram, the resolution between these 2 peaks is good, but looking at the other chromatogram, we find that the column or the chromatographic system was unable to differentiate between the 2 peaks, and hence this resolution here is very low. It is advised, or the acceptable limit for the resolution parameter, that it should be greater than 2. Okay, the next parameter is the tailing factor, or T. Tailing factor is calculated by dividing the width at 5% of the height over 2f. So, for a certain peak, this is the peak front, the first part of the peak is the peak front, and the next part is the peak tail. First, what you're going to do is measure the height, and then at 5% of the height, or 0.05 times the height, you are going to measure 0.05 of the height and then calculate the width at 0.05 of the height. This will be W0.05, the width at 5% of the height. Then you're going to calculate F. What is F? You're going to divide the peak into 2 parts. The first part is F. The width at the baseline of the first part is F. So now that you have measured F, you can easily calculate the tailing factor. Here there are 3 examples of a peak. The ideal case is that the peak will be symmetric and then its tailing factor will be equal to 1. If the peak is tailed, as in this case, the tailing factor will be greater than 1, and if the peak is fronted, its tailing factor will be less than 1. The acceptable limit for the tailing factor is that it will be less than or equal to 1.5. So now that we have discussed all the system suitability parameters, you are required to answer 2 questions. The first question, here there is a chromatogram having several peaks, A, B, C, and D. You are required to calculate the following parameters for this chromatogram. Okay, in question number 2, you are provided with the peak area of different concentrations of compound A. You are required to calculate the unknown concentration of the solution in milligram percent using regression equation. So, in order to solve this question, you'll have to solve it on an Excel sheet in order to calculate the slope and intercept. Given that the peak area of the unknown concentration is this value and the retention time is 3.75. You are given different concentrations, okay? This will be your x-axis and the peak area will be the y-axis. Draw this calibration curve, all right? Calculate the intercept and the slope, and from this calibration curve, you will be able to determine the equation of the straight line. After determining the equation of the straight line, then you will be able to calculate the concentration of compound A, given that the peak area or the value for y is this value, okay, and substitute in order to calculate x, which will be the concentration. So the equation of the straight line is y equal a plus bx. After drawing the calibration curve, you will have y equal a, and you'll have a value for the intercept, plus b, which is the slope. You will have also a value for the slope, and x. Substitute in this equation of the straight line for y with this value, and x is unknown. So y minus A over B equal x, which will be the concentration of compound A. You need to watch out that the concentrations here is given in microgram per milli, and you're required to calculate the concentration in milligram percent. That's all for today. Thank you.